Okay, good morning everybody. So, welcome to SOS webinar. We are going to start, this webinar is about news from FTDI, their graphic processor FT800. Our presenter today will be Graham Simpson and Gary Moore. So only I would like to ask if you have any question regarding software WebEx and its functionality, please contact admin. Regarding the question for our presenter, please write your question to Q&A window, and during the webinar we will ask to our presenter. So now let me pass microphone to Mr. Green to start his presentation. So, good morning, Graham.
Good morning, everyone. Thank you for joining us today. Before we go any further, can I just confirm that the screen is working okay? We should be able to see just the front page of the presentation. Introducing.
Okay, we can see the screen and also we can hear you clearly.
That's perfect. That's perfect. Okay, I'll just carry on with the presentation. As Mariama said, my name is Graham Simpson from FTDI. We're based in the UK. If we start to speak a little fast or you cannot understand, then if you just tell us in the question box and we can pick it up and repeat anything we need to. Joining me today is Gavin Moore. Gavin may be familiar to some of the people on the call, on the webinar. He is the team leader of our customer support unit for FTDI in Europe. And what we want to do today is to introduce you to our latest product, which is the embedded video engine, or the FT800. And here we will be talking about how we will allow you to have graphic display designs made easy. So I just need to get the next slide. So FTDI are a privately owned business. I'd like to just introduce where we've come from to explain what we are doing. You may be familiar with FTDI from our USB solutions and our product strategy of USB made easy. Now, in the modern world, USB is a familiar interface. We've extended that out. We've seen that there is a marketplace for more human interfaces and touch screen and display technology. So our design centers in Glasgow and in Singapore have worked over the last 18 months, 2 years to prepare the FT800 product line, which has 3-in-1 functionality on a single chip, which is display, audio, and touch operations. What we'll do now, I'll just show you a short video, which is on our website. It's just really showing you what he's doing. I'll just let that play in the background as I go through what it is we'll be covering off in the presentation. What we hope to do is to allow you to start to integrate display technology very easily. I apologize for the music playing on this as well. Okay, so This is all available for you online, and also the presentation from the webinar can come back through SOS after the webinar if you wish. So what I'm really looking to do now is just to start talking about the FT800, and then Gavin will start to introduce you to it in more detail. So you will hear us refer to the word EVE. Now, EVE is our character, I guess. It's our tagline for the FT800. FT800 is the IC, and it's the first solution within a new family of products. We have a roadmap, which we will discuss later also. As with our FTDI USB solutions, we'll do the hard work. You can concentrate on your application and let the display, audio, and touch be handled by FTDI. So why and how did we do this? Well, quite simply, looking at this display screen here, this is a typical historical block diagram of where you would require hardware in order to achieve the high quality and end product offered by the FT800 or EVE. Not only do you require a high powerful top quality 32-bit MCU, which you can see in the green box, but you would also require additional components such as a frame buffer in the blue, a touch controller, a separate audio chip. All of these take up valuable board space within the product. So how did FTDI change it? Well, this is the layout of what we use for an FT800 design. So you can see instantly that the board space is considerably smaller. We have the FT800 in blue. Notably, on the left-hand side, you will see there is a low-end, low-cost microcontroller. Now that's because the 800 does a lot of the actual graphic processing. What you're really looking at is you don't need to spend the same amount of money because you have a lower-end MCU, you have a very standard basic display panel, and you don't need as much board space. Essentially, you can use any controller which your application is already running with, so long as it has an I2C or an SPI interface. This allows you to remain familiar with the controllers that you already have, and it allows you to be comfortable as you design in the FT800. So here, and Gavin will explain this in more detail later, the key message that you're looking at is FTDI have removed the traditional setup, the traditional paradigm of what is required for display architecture. So, as shown on the block diagram of the internal architecture, which you're looking at just now, FT800 has some inbuilt widgets allowing engineers to work with objects, i.e. the widget, instead of frame buffering. Therefore, we reduce the data requirement. These widgets are also available both in graphics and in audio, and it allows for you to have easy implementation. Again, Gavin will explain this more later on in the project, but where would you benefit as a commercial customer in terms of the FT800 against some of the more traditional options on the market? Well, I've mentioned the cost and space saving benefits, and there's also the design features. This general example here gives you an idea of why we can secure these benefits. So at the bottom, you will start to see some of the sample costs. In the diagram, in the graphic, you will see that there's a massive difference in terms of the hardware required as well. So all in all, this allows us to then suggest to you as a customer for high volume solutions, say 100,000 pieces per year, you can achieve a complete human interface, graphic user interface solution for $18 to $20. The individual component costs are listed at the bottom. there are some more benefits to be considered when you do look at this, though. And that starts to become apparent when you start to see some of the familiar controllers and the programming tools that you might already be familiar with. These are all compatible and work well with FT800. So, as an engineer, you don't need to learn a whole new controller. You can work in a familiar environment. Then, when you consider that the graphics can be developed within these familiar environments, maybe Visual Studio, or even the Arduino environment, which many people use for development, then we'll support you. We will give you some sample application code free of charge from our website, which allows you to start proceeding with your design. This collateral, we'll show you where to access this later in the webinar, but this really just comes on to show you that we give you everything you would expect from FTDI with this new technology. The data sheets for the IC and the modules, these are given, of course. But then we also give you a programmer's guide. We give you some application notes that will talk you through a basic design example from the very first stage right through to securing your design working in practice. This is application note 240 from the ground up. Gavin will talk you through some more of these later on. I would also stress that these are examples to help you get started, but FTDI offers free technical support. This is available 24 hours a day, 7 days a week. Our company works on a global clocking system, so we're always there to answer you, and we monitor our answers on a 48-hour success rate. For the customers who perhaps, even with this, excuse me, even with the additional information and documentation, some customers don't want to feel comfortable about doing their own designs. So what we've done with FT800 is realize that it is very new for many customers to work on graphic user interfaces. And we've gone and we've partnered with a business you may already know called Microelectronica. Now, Microelectronica have prepared a package that they offer to the marketplace, and that is allowing you to see this example that's on your screen at the moment. Now, this is a tool that they prepare. Rather than having to design some of your own widgets and put down references, you can literally drag and drop widgets from their library of pre-compiled ideas and options, and you can put that in your design. So you'll see more of this. We can discuss this in more detail. But for now, I think let's begin to see how FTDI can simplify the design ideas. So what's the summary? What are we trying to do? We offer good financial value from the initial development module right the way through to the final design. FTDI can offer a single IC. We can offer a module for development or for embedding into an existing solution. And we also offer it in a finished, polished bezel, secured, which would allow you to use that as a final solution. We cover all the ranges there, and we'll look at the hardware options later in the presentation. But let's begin to show how this offers display and touch interfaces to many different application ideas. Oh, sorry. These are just a few of the company who we've started to speak to directly and who are distributors in SOS. Some of the areas whereby FT800 has proven to be very successful, and you might want to consider this yourself. What am I offering at the moment, which has a traditional USB interface perhaps, or it uses hardware, when we could in fact use it for a touch control system. You can see here white goods have been very popular, home automation systems, anything that really involves a human being interfacing with the hardware. So for now, we'll just we'll move on. Gavin's going to talk you through some of the technical features. We'll just go back to check and see if we can have any questions that we've not answered as yet.
Okay, we had one question. Hold on, please. Second, okay. Is sound amplifier needed at sound output?
Is an amplifier required for sound output? Was that the question?
The question, you can also read it in a Q&A answer. Is some amplifier needed at sound question, or I can pass the microphone to Mr. Rybak as by himself. Hold on, please. Okay, Mr. Rybak, you can ask. Can you hear us? Okay. Hello?
We can answer it with that.
Okay, so please, Rim.
Okay, yes, so on our modules we do have a small amplifier chip, and I will show you the block diagram later on of the audio output using pulse width modulation. We can send you the schematic from our modules.
Okay, so we have no other questions, so we can continue.
Okay, we'll proceed. I'll hand you over to Gavin, who's going to talk to you about some of the technical features.
Thank you, Graham. Okay, so we'll just start with a short video, giving you a wee overview. And before we start it, this is the credit card module, which we have available on our website. And you can see here, pointing to the input to the actual board, which will be SPI. We're currently using our MPSSE high-speed cable for SPI. The FT800 connects, and then in the output is RGB to the resistive touchscreen, in this case a 5-inch. And as Graham mentioned earlier, we've got audio out and a small speaker on this board. This is just one of the, first of all, you have to run a calibration so that the screen's actually calibrated. We're now just going through some of the widgets that Graham mentioned. These widgets are available within ROM on the FT800, and you can call them using their code examples that I will show you. So just a recap there, we have the 800 chip here, and we have our MPSSE cable. Now, this cable is acting as the microcontroller. So it's connecting to, in this case, a laptop, and the laptop is a microcontroller. Okay, so how does the 800 lay out? As you can see, we have our in and out. So on our left-hand side, we have our SPI connection or I2C. It would be one or the other. Then we have down the bottom our clocking, which is 48 megahertz, and we have obviously our power supply. On the right-hand side, you will see our outputs going to RGB, which will be going to the screen. We mentioned the audio control, which is pulse width modulation, going to the audio out. The audio is mono. And finally, we have the touch control, and it's using an analog to digital converter. Okay, some of the key features. We use this object-oriented approach, where we have rendering image in a line-by-line fashion. Now, the resolution we have down to is 1/16th of a pixel, and this means much more accurate displays. For example, you saw the list of applications Graham showed you. We had one application where it's signing for a parcel delivery on a handheld system. In this case, the ones we had seen before were not very neat for writing sharp images, or i.e. writing your signature. So the 1/16th of a pixel makes a big difference there. The 800 is built-in anti-aliasing, and this allows for smooth edges on normally in a lower resolution jagged edge you would see. And we have coloured other, and also the RAM export. Now we mentioned before a display list. The display list is what is used for each screen. I'll explain a bit further detail on that in a minute. So the other key features in the audio and touch, I mentioned it's a mono audio, single pin output, pulse width modulation. We have the 64 synthesized voices and sounds. These are stored within ROM, as we mentioned before, as part of the widgets. So you just call these from ROM. It also allows audio wave playback, and it allows for coding format from 8 kHz up to 40 kHz. Then on the touch side, we mentioned it's a resistive touchscreen. Now, Graham touched upon the FT800 being the first in a family, so we will be looking at other screens, capacitance, for example, and various sizes. At the moment, we are currently looking at 3.5, 4.3, and 5-inch screens. And the last thing I want to mention in this slide is the firewire control. This allows for screen pressure to be measured. We have an example app where it's a stress gauge, where you press on the gauge and the gauge increases. This is only possible with a resistive screen. Here's one of the widgets and just the 4 lines of code that we used. You can see here it's a clock widget. Now, this would be if you're writing the code yourself or if you were using one of our sample applications. Alternatively, Graham also mentioned the microelectronica, TFT software. This allows you to just click on the actual clock, and you could click on the hands to change the color, change the background by clicking on the background, or you could resize. Then the C code would be written for you. But in this case, it's just giving a quick example of how you would set this up. So you would have a start, you would set the current time, set the display, and then do a swap command. So complex graphics available for GUI integration. Okay, here's some screen capture shots, and this one is basically a graph, and it's again showing you this particular widget is called bar graph, and you can see it uses plot bar graph, command text, command display, and then you do a swap command. Again, we'll show you this actually in action. Okay, so we've just explained about the widgets, and remember they are held on ROM, and there's a whole library of them. I'm just going to show another short video, which is again showing the same credit card board with some more widgets. You can see here various fonts, and we have the ASCII code set included. If you require additional, we have a font utility conversion application that we can show later on. And here
you might use these in different applications, like for having the font. If you have perhaps different office blocks that want to use this for door entry, that have their own corporate branding, you might want to have the different fonts. You might want to have the different logos moving around that on perhaps a printer or a telephone. These are the kind of examples where we can help with all these fonts and pre-compiled widgets.
Yeah, there was another good one here which you can't see very clearly, I'm afraid, but it was the map showing sat navigation. It's not doing it's very clear for you to see, but it's another example using like a GPS sat nav idea. these are all made up from the widgets within the ROM of the FT800. Okay, I touched upon there the font conversion, and these are three applications that allow us to do that. So here we have font conversion, which is Windows utility for formatting fonts to bitmaps, such as that you can use. So basically, if it's out with the ASCII, so it's an extended ASCII, if it's a foreign language, it could be Chinese, for example, we have this utility that allow you to copy your own formats, fonts into the 800. The other two sample application software we have is an image convert and an audio convert. So the image convert is basically, the 800 will accept JPEGs, but if you have bitmaps or other formatted images, you can reformat them using this utility. The one thing it doesn't do is resize, so you need to have the right size for your particular screen before you use the conversion tool. And similarly, the audio conversion tool is basically allowing you to convert, let's say, MPEG music into a format that the FT800 understands. Okay, so a summary. We're making it easy for designing. We used to have USB made easy, and now we're following the same philosophy into display made easy. It's got three functions: display, touch, audio. The color set is 262 plus 2-bit color data with RGB interface to WGVGA displays. Again, I've mentioned the sizes. We currently have our sample code written for, which is 3.5, 4.3, and 5-inch screens. The FT800 runs at 3.3 volts, and it's relatively low power at 35 milliamps. It's a low pin count. We have one package, it's 48 pin, and it's a QFN. The package size on your PCB is 7 millimeters squared. I'll not go into pricing because Graham will go into that later on in the presentation. Now, the last point here is what voltage you can set your IOs from the micro. So it's between 1.8 volts and 3.3, which you'll find most typical low-cost micros run at. Okay, so that was just a short overview of the technical part, just giving you a bit of the block diagram. And the key point is how the widgets can be used from the ROM and how you can simply do a bit of coding to call on the widgets. I'll give you a wee bit more detail in the actual coding, and I'll go up to a few lines of code later on in the presentation. So I'll hand you back now to Graham.
Yeah, so again, if there are any questions which arise when we're talking about the technical features, appreciate there's a lot to take on board. So feel free to just enter them as we go through. You don't need to wait for the Q&A. And also, if you want to come back to us afterwards, then our email addresses will be available at the end. So what I'll do now, I really just want to talk you through what's available already on the marketplace. Now, as we've always done in the past, FTDI provide everything you need, really. It's a one-stop shop. Now, there are other options that you may want to purchase, perhaps different power supplies through SOS that you're familiar with. Excuse me. That's your choice. We have no problem. All we are doing is trying to show you that we can offer you everything from a basic evaluation board right through to the IC, or perhaps even the stylus, the pen effectively that you use for the screens to get the best quality. or even the USB to micro USB cables that you would use to connect it back to your PC. So what I would say is the products you're looking at here in up in the top of the screen, these guys are credit card modules. We then offer them in a more professional finish with bezels such as these, and this is obviously their accessories. The chip is a QFN package, as you can see. These are the first products to come out from the FT800 and EVE range. We are looking at more of these. There will be another product released towards the end of the year, and this will have an even larger capability with a microcontroller on board. We'll talk about that when it is released, and we can speak to you directly or through SOS. Now, if you want to design it in, you obviously have to factor your bill of materials and how much it's going to cost you to design the product. So, as you can see from this here, the FT800 does drop quite considerably as your volumes increase. You're dropping right down from $3.75, $4. Maximum, like for a single unit, you'd be about $4.50 for the IC. The modules can then come in ranging from sort of $50, $60, but we'll speak to you about that a little more shortly. And this here really just starts to show you how we can help you with the more complete solution. So we have a display there. It's a standard low-end display from ATOP. Gavin's talked about these previously, including the audio amp, and it has its connectors to mate with the controller via SPI. You do not need to have a display. If you want to purchase this without a display, you can. The pricing is shown at the bottom there. So as you'll see, for the smallest of the boards set up for a 3.5-inch display with no display unit, it's $35. On the other hand, if you want to have the larger of the screens, 5-inch module with the 5-inch display included, then you're looking at $75, which, when you factor in all the components, remains a very competitive price. Moving on now to look at what we call our basic board. Now, it can be a little confusing when you use the word basic. The idea we were going for is that this is everything you need in order to have that as a finished solution. So if you don't want to be involved in any complicated sourcing of specific displays or anything else, our basic board is what you want to go for. Now that, as you can see, has the module, which is securely fastened into a customized lock effectively on the back of the screen. And that screen can then drop into your existing product, your existing application, offering you a professional finish that the customers are not going to notice is an upgrade. That also comes both in black and in the silver pearly colour that you see displayed there. Sorry, so I mean that is really where we're at the moment in terms of hardware availability. As I say, there is more coming later this year, and our design team are already processing through the next versions, which would be FT801, and there's further to follow. We're looking at capacitive touch solutions, higher resolution solutions, and different sizes of screens as well. So hopefully you can see that this is but the start of the FT800 history and its future. We'll now proceed on. If there's any questions, let us know about what's available, what's not available. But I think it's more interesting for Gavin to start talking you through about what you need to do in terms of the development flow, and how do you design in EVE?
Thanks, Graham. Okay, so as Graham's mentioned, I'm just going to go over how you would simply plan your project for introducing the FT800 and how you would hook up your display. The block diagram, this is the one Graham showed you earlier, and it's key to show here that it's a low-cost micro that we're connecting to 800, and all that is required from that is I2C or SPI. We then have our output via RGB and our touch input back to the chip, and finally the audio output to the speaker. What processor? So 8, 16, 32-bit are all suitable. The only differentiation they must have is whether it's SPI master or I2C master ports. And you must obviously have a compiler tool to be able to compile your C programming. Now, why we've put here not the FT800 is the code you write will reside on the microcontroller. The 800 is acting as a bridge between the microcontroller and the display. This slide was shown earlier. I just want to bring it back up because it's relevant for this point. Now, I've written some application code using our Visual Studio, Microsoft's, and we've even done it on Visual Studio Express, which is a free download. But you may want to use some of these other tools. The way I see it is a graphic designer will be used to a particular microcontroller that he's used for other projects, and therefore he will be used to using the tools. So, for example, using the AppMega chip on the Arduino boards, you'd be using the IDE tools that come with that, and that's a free download. The ARM chip, it will be Visual TFT, Micro Pro. Now, these are from Microelectronica, which we mentioned earlier. Code Warrior is used for prescale microcontrollers, and also microchipped PICs. You would use the MP Lab. Again, Micro C can also be used for that. However, if you're used to Visual Studio, you could do any of these. Basically, any IDE that will compile C code to suit the micro that you have chosen. The SPI supports mode 0, and it's up to 30 megahertz, and the I2C supports up to 3.4 megabits per second. Currently, all our sample codes that is on the website has been written for SPI. As it's a new chip, that was our main objective, was to get SPI code up, which is obviously it's a faster code. But we are working on I2C, and we will have some I2C projects available soon. So, next step would be to wake up the 800. It's basically a dummy read to address 0 to configure the PLL, start the clocks, and the chip will come to life. Okay, step 3 would be to configure your TFT display timing parameters. So at the beginning of your code, you would have specifics that will suit that particular screen. Screen size, screen resolution, horizontal sync, vertical sync, these kinds of parameters. The 800 has 10 registers that are included to set the synchronization. Now again, Graham touched on the data sheet and the programmer's guide. These are the key 2 documents. The programmer's guide lists every register on the chip and every command that can be used in the chip. Step 4 would be configure the TFT display for touch. It's only used if you require touch. So we have had many applications from customers where they say, we don't need touch, that's fine. However, if you're going to use it, there's 6 registers to control the sensitivity. I mentioned earlier a display list. So the display list would be one image on the screen, and you build up multiple display lists to create what your final project will be. So you get up to 8K RAM, which is 2,000 objects. And when we're talking about objects, we're talking about widgets from the ROM or custom widgets that you've created yourself. You would then do a complete and swap the display list. Finally, you'd compile and load the code into the system processor. That's key. We mentioned that earlier. The code will reside on the microcontroller, not the 800. Okay, so the next section here is software development. And this particular video I'm going to show you is how to create a short widget. And you can see from a screenshot here, once we start it, is we have the code on the left using Visual Studio. We have a video on the right just showing the display, and the bottom right is a command prompt. You'll see when the code runs, remember we need to wake up the device. We get a 7C read back from the register to see that the 800 is connected correctly. So this particular example is showing what we call points, and points or circles. And you can see my codes here. And all I'm going to do is draw 4 or 5 points or circles on the display. And I will also run a short delay and loop this code so that we can see one of the points moving about, one of the circles moving about. So you can see here in point to the point size, you set the color, set the point size, and then you set the coordinates. Where do you want to put it on the display? Now this would be, if we just stop a second, this would be, okay. So for coordinates, 0, 0 is always the top left-hand side. So the coordinates here would be it's not very clear, so it would be 90 by 30, so that would be 90 in, 30 down. This one here is a random coordinate, so every time the code is looked, it will give a different coordinate. So it's now just stepping through the rest of the points that have been written. And you can see I'm setting a different color for each one and a different size. Finally, at the bottom, we will do display, which will display the image on the screen. And this is my short delay. As I mentioned, I'm going to loop the code so that you can see that one of the points will move from these random coordinates. So I should go ahead and run the code. And if you watch the display on the right, you will see my points here. And the large red one is the one that is, every time the code is looped, a new coordinate is given randomly from that command, and you can see it moving about. And you can see that the 3 other points that I've already created. So just a short one to show you a small bit of code to easily draw some circles on the screen and add in a bit of animation. Okay, so the graphics processor, it's a display list based processing. It's line buffer. We mentioned the resolution maximum is 512 by 512. And we have all these widgets again that we mentioned that are already in the ROM. The points one here is the one we've just gone through. We have lines, rectangles, strip, edge strip. So an edge strip is when you fill in to the left or to the right of your strip. And we have bitmaps. So a bitmap could be an image of your own. It could be your company logo, it could be the FTDI company logo, and you would access the bitmap. And on our demo boards, we use an SD card to hold our bitmap files, and you can call them and show them on the display. We have other functionality, alpha blending and stencil buffer functionality. The alpha blending you can see on the left here, and it's where you can actually set translucency and gradient. The stencil buffer is when you've added 2 colors together and you set the command, and whenever they overlap, it will reset to another color of your choice. Bottom left is a gradient, so you can see the blue to the red The gradient command has been added there, so it's not just a straight line border from one colour to the next. And then we have further list of widgets. I mentioned earlier the clock widget. We have a dial widget, sliders, and a QWERTY keyboard, and like toggle type switches. Other toggle switches here are yes, no. So you could change that text to anything you want. On, off, for example. You could change the colour. These are dials that are different from clocks and that allow you to, I don't know, set a volume, set brightness, that kind of thing. And we have text, and this final one is like a please wait. So continuing the graphics processor, the performance is typically 480 by 272, and it's 1/16 of a pixel. And the bitmap formats are available are L1, L4, L8, and various RGB formats, including text, VGA, and palette. We have filters, linear and bilinear, and functionalities like rotate, scale, and translate. So you can see here we have a bitmap with scaling, and we can reduce the size. We have a bitmap with rotation, and finally we have a bitmap with flip. Okay, so this is a block diagram basically going over how the processor is getting the data through to the screen itself. So the direct write would be using the display list, and this would be, for example, the simple points or circle being driven through the buffer to the graphics processor. The GRAM would be dealing with raw data, so this would be a bitmap image. And finally, our FIFO, it will be dealing with more complicated widgets like calculation, clock, that kind of thing, when you're having to set a time for the clock. Okay, we've reached the end of that section.
Okay, so I don't think there's only one question which has been brought to us, which was I believe to see the coding in the video a little bit clearer.
Sure.
What we'll do is we will send you over the actual video link. You can access that, or we can probably send you over the actual code, and you can just start to look at it yourself that way. That will allow you to pause it and access the code, zoom in if you wish. Unfortunately, the presentation example is really there just to show you this is how simple it would be. This is how few lines you require to write the code, and how fast you can actually do that.
Just a point on that, Graham. The example codes are all on our website, and you'll be able to download any of these codes. That particular one will be under points. That's just a simple one I did. I think we've got up to 14 examples. We've got another short video coming up that will show you whereabouts to find these on the website.
Okay, so if there's no other questions at the moment, then we'll just proceed on.
Okay, so we've covered the graphics of the 800. So now we're going to look at audio and touch. And the audio is inbuilt synthesized sound playback, so it has, just like the widgets, stored information on the ROM. The playback is 8-bit signed PCM, and there's 4-bit AD PCM sample, and the sampling frequency is between 8 and 48 kilohertz. The playback modes are one shot and loop, and you can mute sound on a power down. The touch processor, it's a resistive touch, and it's a single touch. It also does pressure sensing, and it's a direct analog to digital converter. It has inbuilt mid-range filter for touch samples, and the modes for touch are off, one shot, frame continuous. Okay, here is that in a block diagram. You can see on the left our audio data control path, and on the right our touch data control path. And we have the audio processing unit to the speaker. We have raw data going through the GRAM, and we have an audio ROM. So again, this is where the actual audio is saved on the ROM, where you want to choose from one of the polyphonic sounds that we have included there. Remember, you're not restricted to that. You could use your own sounds, recorded music, for example, or speech. And using our converter tool, you'd be able to have it ready for the 800, and it would go through as raw data. And finally, we have the configuration registers. On the touch side, we have the touch processor and the configuration registers.
Okay, so we'll just carry on. It doesn't seem to be any questions coming through. So really, in terms of where do you go from here? If you wish to access this hardware and to start working with it, then I would suggest that you go to SOS Electronics. SOS have been a distributor for FTDI for some years now, and they are a technically qualified distributor. That means that they are aware of the technical questions that come up. They have some of the basic answers and access to all the documentation. They have a fast time to market. They've already got this stock in their warehouse, and they can release goods to you very soon. So I would recommend that SOS are your first point of contact for the best value, the best delivery, and the best support. Once you have that, you can always feel free to come back directly to FTDI, preferably in copy of SOS, and we can help to answer any design issues you may have, or any support issues, or any other questions on the commercial front. So Gavin mentioned to us earlier about where can we find all the information. As we said, it's all on our website. So this video is really just to show you a rough overview of where we are in terms of the FTDI chip website. So we have a dedicated page for EVE. You'll see this here. This is the EVE landing page. Now, when you go on to the YouTube channel, which there is a link, you will see that the demos, which we were speaking about earlier, these are all available on the website for you to watch, just to get a feel for. If you scroll further down, you'll start to see a lot more familiar block diagrams, information relating to the hardware, the basic setup that you would require for your FT800 design. Also summarizing the modules, the hardware that is available at the moment. But more importantly, and you'll see soon, we also have all of our application notes. So the data sheet, the brochure, the programmer's guide. I would stress that the programmer's guide is a very good document to read before you start to evaluate. Make sure you're comfortable with that, and then proceed on from there. And you can start to look at the design samples. The clocks, the widgets that Gavin was running through, they're all there. And also at the bottom, there is a link back to Microelectronica, should you feel that purchasing their pre-compiled library, their TFT, is the correct way for you as an individual to go ahead and start the design with FT800. So one thing that I believe is due to occur shortly, SOS have been kind enough to congratulate some of the participants of today's webinar with a sample of our module, and they will be in touch with the lucky winners, of which there's a prize draw going to occur immediately after the presentation. So we'll go ahead and let SOS deal with that. I see another question has arrived to ask about the refresh rates of the display. Gavin, do you want to?
I don't have that right off the top of my head, but I can certainly take a note of you and send an email. So we get an email address from us?
Yeah, okay, so Backlab, if you could just send us your email address, we'll reply to you directly. We'll need to go and confirm that information. So moving on, just quickly, just to summarise and provide you with some details for any other questions you might have for FTDI, for the EVE family, or perhaps even for the USB family. This is the contact details here. As I say, I recommend SOS as being your first point of sales. I would, however, be happy to answer any commercial pricing inquiries you want to confirm with myself on the email address provided on this screen, or perhaps if you have any design questions or technical questions, then we can answer these on Gavin's email. So you might want to just take a few moments to take note of those email addresses. We're based in the UK, so typically we're in the office 9 to 5, Monday to Friday, should you need to get hold of us. You can call us on the telephone number also. There are some questions coming through just now, so we'll just start to answer those as we can. I think these are mainly coming through directly from SOS, but please do, if you have any questions, please do start to bring them to us just now. We will remain online. And I'd just like to say thank you to SOS for preparing the webinar function. We hope it's been helpful for you and useful, and we'd encourage you to carry on your interaction with SOS for any FTDI purchases with your business.
Okay, so also thank you for your presentation. If there is any question also after this webinar, please contact us and we will answer your question regarding FTDI product. Also, after this webinar, there is a short survey, so please, if you can fulfill it, as already been mentioned, you can become a winner of some breakout module. So, one more time, thank you everybody for attention. Thank you, Grim and Gavin, for your presentation, and have a nice day.
Yeah, we'll just stay on online here. There's a few questions coming through, so
okay.
Yeah,
okay.
we can reply to them. So right here. So David asked a question: do you know about some designs for Raspberry Pi using 800? And it's funny, we had a customer ask a very question last week. We currently don't have that, but I know some people are trying it. But we don't have, we've not actually tried it out with Raspberry Pi yet, basically. But we don't see why not. So when we get any project information, I can certainly send this to you. Are you able to give me your email address, please, David?
Alternatively, you could just ask for this through SOS. That's probably a better way to do it.
Okay, thank you.
So we've actually got some information here about the refresh rates as well, relating to the earlier question. So for the VQVGA, the 480 by 272, the refresh rate is 60 Hz for a typical configuration. So on a 480 by 272, it's a 60 Hz typical refresh rate.
Yes, so that the question earlier was, can we get higher than the 60? So the typical refresh is 60. So I'm not sure what we can increase that to, but if you could send me, I'll send you an email regarding this, and we can see if we can maybe help with your code to stop the flicker that you're seeing in your display.
Green, we got one more question, so we can answer it.
Sure.
How big is GRAM for sound purposes?
Let me just check this.
We'll just try and get that information for you, if you bear with us for 1 minute. I'm just going to take it from the data sheet here. So if you just bear with us for 1 second.
Don't know if we actually quote it.
Igor, we'll come to your question in a second. We're trying to find the answer to Imri's question.
Yeah, I don't think it's quoted within the data sheet. I'll need to find out if we're able to share that information. I'm pretty sure we are. I don't know why it's not in the data sheet. But I will send you an email.
Imri, can you send us your email address, please, so we can reply to you directly? Thank you. Okay, so we'll now move on and try to answer Igor's question.
Igor, could you give me some more information on your question? When you say compiled footprint, do you mean the size of code required for a primitive object?